Hey everybody! In last week's video, we introduced the importance of arrays in Java programming. Today, as a continuation of the Java July series, we'll be expanding on our previous discussion and looking at the intricacies of implementing arrays and their elements for various purposes. We will be starting off our expansion on arrays by exploring array elements and how to use them in your programs. Remember that in Java, it is impossible to access or assign a value to an array slot outside of the array's boundaries. Therefore, it might be useful to test for the length of arrays in your programs before implementing any code that may cause such an error. Luckily for us, there is a length instance variable available for all array objects, regardless of their type. Let's say we want to get the length of the third array defined here. If you want to review on how to create these arrays, be sure to check out last week's video on this topic. We can create an integer variable called thirdarrayLength and set it equal to arr3.length. When printing this value to the console, we see that the length of our third array is 9. Now that we know the length of the array is 9, we can call in any slot in our third array numbered 0 through 8 and print those values to the console like so. Note though that if we were to print out the value in the 9th position of our array, that we would get an error, specifically an array index out of bounds exception. After understanding how the slots are numbered for our array, we can use this information to change the values that exist in these slots, even after the array's initialization. You can also reassign the values of an array to another slot in the same array, as shown here. Note though that changing the values of these array elements in this way does have a different effect on the array based on what type the array is. When you assign a value to a slot in an object array, you are creating a reference to that object. Therefore, when you're moving around the values inside the string array, you are actually reassigning the reference rather than what you would intuitively presume as copying a value from one slot to another. This copying process only happens with primitive data types, like in the int array. In addition to working with the elements of an array, we can store and manipulate values in a multidimensional array. Multidimensional arrays allow us to access more than one dimension when representing elements in our code. Adding these dimensions can be useful, for example, when representing something like a grid of array elements in an XY axis format. While Java does not explicitly support multidimensional arrays, we can implement a workaround to achieve the same functionality. Essentially, by nesting arrays inside arrays, we can add however many dimensions we want for the elements being represented. By just having arrays contain arrays to represent 2 dimensions, those arrays contain arrays to represent 3 dimensions, and so on. The 2-dimensional array in the Java programming language is the simplest form of multidimensional arrays, and is also a topic that makes up 7.5 to 10% of the APCSA exam, as of the 2021 guidelines. In 2-dimensional arrays, data is stored in rows and columns, and we can access the values stored in these positions by using both the row index and column index. Declaring a 2D array is very similar to how we previously created our array variables, by including the data type of the array and its name. It's just that this time, instead of having one group of brackets, we have 2 to represent the 2 dimensions in our array. Next, to define how many rows and columns our 2D array will contain, we use the following format, again similar to how we define the number of slots for a single dimension array. Remember that the values of these slots are assigned to their data type's default value, unless explicitly defined by the programmer to contain a specific value. To define the values in the slot for a 2D array, we can use the following lines of code. Here is the code that allows us to print out the values in our 2D array to the console. We can see how that other than the values we just assigned, every other position has the default value of 0 for our integer array. Similar to how we did it for single-dimension arrays, we can combine all of these declaration and initialization steps for 2D arrays into a single line of code. Remember though that we can only do such a step if we already know both the size of the array and the variables for the array. We can see here how we did not explicitly mention the row size and column size of our 2D array. However, the Java compiler is able to calculate the size of the array by checking the number of elements inside the row and column that we defined. Finally, another similarity between our single and multidimensional arrays is that we can use .length to find the rows and columns that a 2D array has. However, using only .length will determine the number of rows there are in a 2D array. To find the number of columns, we have to set the row value to 0 and find the length of that expression. In today's video, we expanded on our previous discussion about arrays, understanding how to manipulate the elements of both single and multidimensional arrays, along with how to define 2D arrays in Java programs. This is the last video of the Java July series, as we cover concepts ranging from object-oriented programming to arrays these past 5 weeks. Shown here is a breakdown of the topics we covered in this series and how they relate to the APCSA syllabus as of 2021. If you would like a more detailed analysis of the APCSA curriculum and how it relates to all of the Java videos provided on this channel, check out the link provided in the description and on this screen. Hope this helped.